We've covered the qubit details with a specific trapped ion, the ytterbium. And we know that it has two hyperfine states. And the question is, how do we initialize this qubit so that we know where it's starting before we apply gates or do any other action? And the answer is, we do optical pumping. Optical pumping. And how can you do laser optical pumping and get things to go to the low state? And we also need to figure out, how do we measure what the state is? How do we know that we're doing our job and bringing it to the zero state unless we can measure it? So we have to figure out how that works. The hyperfine states depend on magnetic moment. The magnetic moment is part of this spin thing, and that spin thing can be affected by optical means or lasers. We call it optical pumping, but you could call it laser pumping. Let's talk about an analogy where we have two buckets. Bucket here and a bucket there. This bucket represents the one state or the excited state, and it has a small hole in it. This is the ground state, or we could call this the dark state, because when we measure it, we'll just get nothing back, or the dark state, and when we measure this one, we'll get a light state back, because it will, well, we'll go into measurement later. So, if this has a hole in it, then some of them are going down to the ground state, but some of the ground state ones are still active, and it's going up to the upper state. If we have things in the middle state, because quantum mechanics tells us there is this middle state between these two, that these things can act. So they have a probability that they're going to get to this upper one and a probability that they're going to get to this lower bucket. So some of them keep going into the upper bucket, and so it keeps getting filled even though it's draining out into the lower bucket. So what we want to do is actually excite all of the population to go into this upper bucket, because this upper bucket will empty out eventually. So we use the polarization to affect only those that are above the ground state. The optical thing is polarized such that it only affects the magnetic moments that are going to go into the upper state. So all of the population goes into this upper bucket, and as it drains down, eventually all of the ions end up down in this lower ground state. So that is the process of initializing the qubit. Now that we've got the qubit analyzed, we need to figure out how to measure it. Now, when we measure it, remember that some of the magnetic moments could be in that between state. Now, the way we've initialized it right now, none of them are in that upper state. So, what do you expect our measurement to be? Our measurement will be nothing. So, we send a laser to excite whatever is there, and if it's in that upper state, it has a chance to go to the down state, and when it goes to the down state or the lower state, it flashes a little light or a little pulse of light, and that pulse of light tells us that that thing just dropped to the lower state, so that meant when the measurement was taken, we actually had a light state. Now, if the qubit is in the low state, then we try to shine the light but there's nothing there. There's nothing to excite, and we can't see anything, so that's the dark state, which is a good analogy. In other words, if we don't get the light back, that's 0. If we get the light back, then it's 1.